NENOMATICA, where mathematics meets YouTube excellence. Welcome to this lesson on polynomial long division. Today, we're going to work through dividing the polynomial 6x to the fourth minus 7x cubed plus 10x minus 23 by the polynomial 3x squared minus 2x plus 5. First, let's set up our long division. We'll write the divisor, 3x squared minus 2x plus 5, on the left side of the division symbol. And under the bar, we'll write our dividend, 6x to the fourth minus 7x cubed plus 0x squared plus 10x minus 23. Notice that I wrote 0x squared to keep our terms properly aligned. To find the first term of our quotient, we need to divide the highest degree term of our dividend by the highest degree term of our divisor. That's 6x to the fourth divided by 3x squared, which gives us 2x squared. So we write 2x squared as the first term of our quotient. Next, we multiply the entire divisor by the first term of our quotient. That's 2x squared times 3x squared minus 2x plus 5, which equals 6x to the fourth minus 4x cubed plus 10x squared. We write this underneath the dividend, aligning like terms. Now, we subtract this product from the dividend. That's 6x to the fourth minus 7x cubed plus 0x squared plus 10x minus 23 minus 6x to the fourth minus 4x cubed plus 10x squared. After subtraction, we get negative 3x cubed minus 10x squared plus 10x minus 23. For the next step, we divide the leading term of the remainder by the leading term of the divisor. That's negative 3x cubed divided by 3x squared, which gives us negative x. So we write negative x as the second term of our quotient. We multiply the divisor by negative x. That's negative x times 3x squared minus 2x plus 5, which equals negative 3x cubed plus 2x squared minus 5x. We write this underneath our first remainder. Now, we subtract this product from the first remainder. That's negative 3x cubed minus 10x squared plus 10x minus 23 minus negative 3x cubed plus 2x squared minus 5x. After subtraction, we get negative 12x squared plus 15x minus 23. For our third step, we divide the leading term of the remainder by the leading term of the divisor. That's negative 12x squared divided by 3x squared, which gives us negative 4. So we write negative 4 as the third term of our quotient. We multiply the divisor by negative 4. That's negative 4 times 3x squared minus 2x plus 5, which equals negative 12x squared plus 8x minus 20. We write this underneath our second remainder. Now we subtract one last time. That's negative 12x squared plus 15x minus 23 minus negative 12x squared plus 8x minus 20. After subtraction, we get 7x minus 3. Since this has a degree less than the degree of our divisor, we've completed the division. Let's summarize our result. We've determined that when we divide 6x to the fourth minus 7x cubed plus 10x minus 23 by 3x squared minus 2x plus 5, we get a quotient of 2x squared minus x minus 4, with a remainder of 7x minus 3. We can write this as 6x to the fourth minus 7x cubed plus 10x minus 23 divided by 3x squared minus 2x plus 5 equals 2x squared minus x minus 4 plus the fraction 7x minus 3 over 3x squared minus 2x plus 5. We can verify our answer by multiplying the divisor by the quotient and adding the remainder. Welcome to this tutorial on polynomial long division. Today, we'll work through a detailed example to show you how to divide one polynomial by another, step by step. Just like in regular long division, we'll set up our work with the divisor on the left and the dividend underneath a division symbol. Here we have our dividend x to the fifth minus x to the fourth minus x cubed minus x squared minus x plus 2. And our divisor is x squared plus x plus 1. The first step is to divide the highest degree term of the dividend by the highest degree term of the divisor. The highest term in our dividend is x to the fifth, and the highest term in our divisor is x squared. When we divide x to the fifth by x squared, we get x cubed. This becomes our first term in the quotient. Now, we multiply this quotient term by our entire divisor. So x cubed times x squared plus x plus 1 gives us x to the fifth plus x to the fourth plus x cubed. Next, we subtract this result from our dividend. We'll change the signs and add. So we get negative x to the fifth minus x to the fourth minus x cubed plus x to the fifth minus x to the fourth minus x cubed minus x squared minus x plus 2. Now we bring down the next term and repeat the process. The new highest term is negative 2x to the fourth. We divide this by the highest term of our divisor, which is x squared. So negative 2x to the fourth divided by x squared gives us negative 2x squared. This becomes our second term in the quotient. We multiply negative 2x squared by our divisor. Negative 2x squared times x squared plus x plus 1 gives us negative 2x to the fourth, negative 2x cubed, and negative 2x squared. Then we subtract by changing the signs and adding. After subtraction, we get x squared minus x plus 2. For our final step, we divide the highest term of our remainder, which is x squared, by the highest term of our divisor, also x squared. This gives us 1, which becomes our next term in the quotient. So our quotient now reads x cubed minus 2x squared plus 1. Now, we multiply 1 by our divisor. 1 times x squared plus x plus 1 gives us x squared plus x plus 1. We subtract this from our current remainder by changing signs and adding. After the final subtraction, we get negative 2x plus 1. Let's summarize our result. When we divide x to the fifth minus x to the fourth minus x cubed minus x squared minus x plus 2 by x squared plus x plus 1, we get a quotient of x cubed minus 2x squared plus 1, and a remainder of negative 2x plus 1. So our complete answer can be written as x cubed minus 2x squared plus 1 plus the remainder, negative 2x plus 1, divided by our divisor, x squared plus x plus 1. To verify our answer, we can multiply the divisor by the quotient and add the remainder. This should give us our original dividend. Let me emphasize that mastering polynomial long division takes practice. The key is to be methodical and follow each step carefully, just as we did in this example. Welcome to this video on polynomial long division. Today, we'll learn how to divide the polynomial x to the fifth plus x to the fourth minus x squared plus 1 by the polynomial x squared plus x plus 2. This is an important skill in algebra that helps us simplify complex expressions and solve equations. Let's set up our polynomial long division. We'll write the divisor, x squared plus x plus 2, on the left, and our dividend, x to the fifth plus x to the fourth minus x squared plus 1, to the right under a division bar. It's important to organize our terms in descending order of degree, and to include any missing powers with zero coefficients to help us keep our columns aligned. So I'll explicitly write our dividend as x to the fifth plus x to the fourth plus 0x cubed minus x squared plus 0x plus 1. The first step in polynomial long division is to divide the highest degree term of the dividend by the highest degree term of the divisor. In our case, we divide x to the fifth by x squared, which gives us x cubed. This will be the first term in our quotient. We write this above the division line, aligned with the appropriate term in the dividend. Now, we multiply the entire divisor by this first quotient term, x cubed. This gives us x squared times x cubed, which is x to the fifth, plus x times x cubed, which is x to the fourth, plus 2 times x cubed, which is 2x cubed. So we get x to the fifth plus x to the fourth plus 2x cubed. We write this below our dividend, making sure to align like terms. Then we subtract this from our dividend, which means we change the signs and add. After subtraction, we get negative 2x cubed minus x squared plus 0x plus 1. This becomes our new dividend for the next step of the division process. For the second step, we repeat the process. We divide the highest degree term of our new dividend by the highest degree term of the divisor. So we divide negative 2x cubed by x squared, giving us negative 2x. This becomes the second term in our quotient. Now we multiply the entire divisor by this new quotient term, negative 2x. This gives us x squared times negative 2x, which is negative 2x cubed, plus x times negative 2x, which is negative 2x squared, plus 2 times negative 2x, which is negative 4x. So we get negative 2x cubed minus 2x squared minus 4x. Again, we write this below our current dividend, align like terms, and subtract by changing signs and adding. After this subtraction, we get x squared plus 4x plus 1. This becomes our new dividend for the next step. For the third step, we again divide the highest degree term of our new dividend by the highest degree term of the divisor. So we divide x squared by x squared, giving us 1. This becomes the third term in our quotient. Now, we multiply the entire divisor by this quotient term, 1. This gives us x squared times 1, which is x squared, plus x times 1, which is x plus 2 times 1, which is 2. So we get x squared plus x plus 2. We write this below our current dividend, align like terms, and subtract. After this final subtraction, we get 3x minus 1. The degree of this expression is less than the degree of our divisor, so we can't continue the division process. This becomes our remainder. Therefore, when we divide x to the 5th plus x to the 4th minus x squared plus 1 by x squared plus x plus 2, we get a quotient of x cubed minus 2x plus 1 with a remainder of 3x minus 1. We can express our final answer in two different ways. First, as a quotient plus a remainder over the divisor, which gives us x cubed minus 2x plus 1 plus the fraction 3x minus 1 over x squared plus x plus 2. Welcome to this tutorial on polynomial long division. Today we'll work through dividing two polynomials step by step, following a method similar to arithmetic long division that you're already familiar with. Let's look at our example. We need to divide 2x to the 10th power minus 7x to the 8th power plus x to the 6th power plus 2x to the 4th power minus 3x squared minus 1 by x to the 4th power minus 3x squared minus 1. Before we start the division process, let's set up the problem in long division format, similar to how we'd set up arithmetic long division. We'll write the divisor on the left and the dividend underneath the division symbol. Step 1. Let's start by dividing the leading term of the dividend by the leading term of the divisor. We divide 2x to the 10th power by x to the 4th power, which gives us 2x to the 6th power. We write this above our division symbol. Next, we multiply the entire divisor by this result, 2x to the 6th power. This gives us 2x to the 10th power minus 6x to the 8th power minus 2x to the 6th power. We then subtract this from our dividend. This gives us negative 1x to the 8th power plus 3x to the 6th power plus 2x to the 4th power minus 3x squared minus 1. This is our new dividend for the next step. Step 2, we continue the division process with our new dividend. Now we divide the leading term of our new dividend, negative x to the 8th power, by the leading term of our divisor, x to the 4th power. This gives us negative x to the 4th power. We add this to our quotient. Next, we multiply the divisor by negative x to the 4th power. This gives us negative x to the 8th power plus 3x to the 6th power plus x to the 4th power. We subtract this from our current dividend. The result is x to the 4th power minus 3x squared minus 1. Step 3. We continue with our final division. We divide the leading term of our new dividend, x to the 4th power, by the leading term of our divisor, x to the 4th power. This gives us 1. We add this to our quotient. Next, we multiply the divisor by 1. This gives us x to the 4th power minus 3x squared minus 1. We subtract this from our current dividend. The result is 0. This means our division is complete, and there is no remainder. Therefore, our final answer is 2x to the 6th power minus x to the 4th power plus 1. This means that 2x to the 10th power minus 7x to the 8th power plus x to the 6th power plus 2x to the 4th power minus 3x squared minus 1 is exactly divisible by x to the 4th power minus 3x squared minus 1, with no remainder. This process is similar to arithmetic long division, but applied to polynomials. To summarize the polynomial long division process, first, we divide the leading term of the dividend by the leading term of the divisor. Then we multiply the divisor by this result and subtract from the dividend. We continue this process with the remainder until we either get 0 or a remainder with degree less than the divisor. In our case, we got a 0 remainder, which means the divisor is a factor of the dividend. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.